Also, if you can, like, keep yourself muted, right? You can show a video, that's fine, but try to, just keep yourself muted. Just to introduce myself, my name is Manoj. I'm from Plotch.ai. I'm speaking from a beautiful city in India, Jaipur. It's raining outside, so it's a beautiful weather out here, but the temperatures here can go up like to 40 plus. So that's why the rain is good here. But yeah, so today basically, let me just set the context first, right? And why we chose the topic, and why we have we have such speakers from two very interesting companies. And I'll tell you why we chose IBM and Kipu Quantum for this webinar, and there's a specific reason for that. Now, quantum computing is not new. I mean, it has been talked for like last 50 years. In fact, IBM is one of the pioneers in this space. They were, I was reading somewhere, they were the first company to actually sponsor the first conference on quantum computing 50 years back, kind of stuff, right? So IBM has been there for quite some time. Quantum computing is not new, since Richard Feynman, who basically told that quantum physics can be used for computing as such, right? So that's what quantum computing came into picture. And it has been there for a lot of years. But what we are seeing today, at least in my view, is a fundamental shift happening. And there is bedrock. The bedrock of quantum computing is quantum computing hardware, right? Which is basically what we call qubit hardware. And that basically is growing, and we are seeing some interesting development here in that space. Now, there's of course lot of hype, or there's a lot of noise about quantum computing, this and that. And a lot of people at least ask me, is that what can I build on quantum computer today, right? And that basically is one of the most fundamental question a lot of people asking. What can I build? And the second question, which is more interesting, is there an advantage for me to use quantum computer today versus a classical computer, right? Which is CPU based and GPU based, quantum computing, right? So the question today, and that's the question, which is hovering in my mind, and that's why I thought, let's do a webinar on this topic itself. And we wanted in this webinar to have representation both from the hardware side and from the algorithm application side. And that's where we have this interesting mix here, which is Kipu Quantum, which basically sits at the algorithm application layer, trying to one of the actually mission of Kipu Quantum is to make quantum computing useful, right? And today, so that is a very interesting thing which attracted me. And of course, the hardware side, which is basically where the IBM starts to come in. IBM, they launched their first, I think, quantum computer in 2019, which is accessible to folks. And they have also have a very interesting software, open source software kit that they provide, which is called Qiskit, which is a lot of people use it. So that's why this combination is very interesting. Now, having said, the broad, why we are doing it kind of stuff, let me welcome our panelist here, Enrique Solano, who today is a technology advisor to Kipu Quantum. He was CEO of Kipu Quantum. He co-founded Kipu Quantum in 2021 in Germany. And I was, looking at kind of publications he has done. He's a professor. He was a professor at University of Basque, and he has published like more than 400 papers. So he's a legend in my view in quantum computing. And so I want to welcome Enrique Solano to this webinar, and we have Guncha Malik, who comes from IBM. She is basically has been with IBM for 16 years, so she understands IBM, inside out in a lot of ways, and she's basically a senior, technology ambassador for quantum computing, right? So she sits in India, and she basically has 25 plus years of experience across variety of domains, and comes with very very strong background in, for example, cybersecurity and those kind of stuff, right? So we have, these two, esteemed panelists. I'm very fortunate to have both of them. Welcome, Enrique and Guncha. Anything you want to highlight about yourself or anything about your company before I, get into my Q&A?
Thanks, Manoj. I'm totally fine with your introduction and thanks for the invitation.
Thanks, Manoj. The only thing I would say is not for myself, but for IBM. IBM has been putting the processors, the QPUs on cloud for 10 years now. So this is the 10th year. So I would like to highlight that. Thanks for the invitation. Happy to be part of this panel.
No, thanks for that, Guncha. So yeah, so first question to Enrique, you, and it's basically, before I get into quantum computing, I just want to, because I came across this interesting story, how you named Kipu Quantum, right? Kipu. So would you want to highlight that here? Because I think that's an interesting angle. I just wanted to hear that. Yeah.
Yeah, I mean that the story is very personal. I was born in Peru, South America. I use my Spanish nationality, but I am very attached to the origins of the Inca Empire in South America, where they use these strings with knots and fabric to encode information. And somehow it got lost in history, the interpretation of them, even though people claim that they understand now, it was hidden in some kind of, religious information. And when I was educated in Peru, I never heard that such quipus, such devices, were meant to compute anything, right? People just try to say information was there. But when I was collaborating with Google Quantum and I was traveling frequently to the Silicon Valley, I entered into the Museum of Computer History of in Mountain View, and I found at the entrance a huge kipu saying that it is part of the history of computing. And then I said, "Oh man, I never heard that." And then I said, one day I will use it for a company. And that's the origin. So Kipu is nothing else than a predecessor of all the digital and analog, classical and quantum computers in history. And yeah, that's the idea.
No, very interesting, very interesting. And I did not know that, so I thought, I'll just bring that out in the webinar. No, Enrique, basically, before we get into the use cases part, right? Some of the folks here might be new to quantum computing as such. Would you want to just shed some light on how is it different from the CPU GPU world? I mean, how is it different? And
Yes, it's a very, very, very good question because that's the way people get to it. It's very, as you said, I have been professor and director of research of international centers, so I happen to also to have some training explaining in simple words. And the simplification is that CPUs, are meant to be processing units that allow a sequence of logical operations along the bits that are the units of information with these zeros or ones. And it follows the historic contributions of Alan Turing and von Neumann architectures from the 50s, 60s. And it has been a paradigm, a revolution in computing, in electronics. Then came the GPUs that are now fashionable for AI. That the difference is that instead of sequence of operations, they allow for parallel operations. They were developed for video games, historically, and for images and so on. And suddenly they found their way on AI, and now they are dominating so sequential CPU, parallel GPUs. And then the quantum brings another revolution that is the exponential growth of the encoding by a property that is called multipartite entanglement. So literally, instead of having zeros or ones, you can have all the combinations in parallel in this explosion of exponential growth. And that's what allows quantum computers to have more computational power and capacity following the laws of quantum physics and not of any more of classical computing.
Great, great. So basically, right, CPU, from at least from what I can understand, like CPU is more like a logical space, and GPU is an intelligence space, and basically with QPU we are getting into the acceleration of these mathematical, acceleration of, and you can basically accelerate a lot of these stuff, which are natural in nature, using QPUs, right? And of course the the entanglement and the superposition, all that is a fundamental part of this QPU. So I think that's very interesting to know. And uh, I mean, let's look at, the CPU became very, very, important when, applications like Windows and all those things, we started using them, started putting application on top of that, right? And GPU became interesting because of AI and LLMs and those kind of stuff, right? QPU has not found that kind of application yet, right? And unless we find that application, right, the QPU is QPU, and may not be useful for a lot of folks, right? So Enrique, the question to you, again, is what useful can we build today on QPU, on whatever hardware is available? What can we do today, kind of stuff? Yeah,
Is it to me the question?
yeah, Enrique, to you the
Yes.
question.
Yeah, I happen to disagree with your first statement that we don't know yet what for, because essentially I have worked on that for
Okay.
the last years. And what the disclaimer I want to make is that we get trapped in the language mostly, because
Okay.
if you ask me, are quantum computers, the hardware, useful today for industrial applications, adding value and creating an important business case? The answer is yes. If
Okay.
you ask me, and I will tell you later how, right? But if you
Sure.
ask me, are fault-tolerant, universal, scalable quantum computers available? The answer is no. You see,
Okay.
so people get confused, and the best way to understand that is going back to your classical analogy. If I tell you, for example, and by the way, I have done this in the past with ChatGPT, just to you can do that. Everybody in the audience can do
Yeah.
that. Say, are CPUs scalable and universal computers following the Turing fundamentals and following von Neumann architectures? The answer is yes. So then the second question is, really, are they universal and scalable and all that? Then why people use GPUs and
Yeah.
not CPUs? And the
Yeah.
answer of ChatGPT is what I'm going to give to you now, is because people confuse universality and scalability with efficiency. And if you tell everybody working with LLMs and AI to use CPUs instead of GPUs, the technology does not work. It's not because it is not universal, but people get in quantum computers is the same. Fault tolerant quantum computers do not exist today, but they are meant to be built along the next years or decades, and they will find their way. But it doesn't mean that the noisy qubits of today cannot be used for important applications, and that's exactly where me and my company, when I created Kipu,
Mm.
as you said, I come from a super successful academic career. I have achieved everything anyone wants. But when I
Yeah.
entered into industry, I said, no, no, or I make quantum computers useful now with noisy qubits, or I am out. And we succeeded. The difference is that it's not universal. It's not necessarily scaling the way people want, but computer scientists brought a language that confused the system. And now people are thinking that without fault tolerance, you cannot do anything, and that's a huge mistake. You will see soon, just the pre-announcement, some press releases from top American and European companies where they will acknowledge that they are going in production with IBM D-Wave for Quera quantum computers in production. I said literally in production. That means replacing classical computing for industrial applications. Some of those companies saving about $100 million per year just because they use our quantum algorithms using commercial quantum computers. And I'm sorry for those that do not believe or question my view, but that's what I call customer quantum advantage. The customer speaks, the customer pays, the customer uses, and that's it. All the rest is not interesting to me.
Got it. No, that's very interesting to hear, Enrique. And it's very interesting to hear that there's already, companies are saving $100 million using quantum computing.
Yeah.
And that's like what you were saying is a customer quantum advantage, right? It's basically
Exactly. It's still, let's say, under embargo of information. I cannot tell you who, but
yeah.
this is going to be disclosed in the next weeks. Yes.
Wow, that's very interesting. And Guncha, coming to you, I know IBM is is a pioneer, as you said. 10 years back they started. To me, basically, IBM is like NVIDIA in GPU. IBM is like in quantum computing. That's basically my personal view. And there's a lot of things IBM is doing. And I think you have hardware and you guys also building the upper layers like Qiskit and partnering with a lot of I heard about Cleveland Clinic, for example. You're working with them for Adam simulation and drug discoveries and those kind of stuff. Do you want to tell about us like what IBM is doing, and as Enrique is saying today, there is usefulness of quantum computer. You want to highlight some of those?
Sure. So IBM is really trying to bring the useful quantum computer to the world, and partners like Kipu Quantum and other partners who are really looking at these algorithms and identifying the use cases which are really going to be useful for business. That is really the important aspect that needs to come together. So just building a quantum computer is not going to be sufficient. And that is where IBM has been really focused on building the entire ecosystem where we are also training the individuals so that we have talent pool readily available when these startups and when other organizations start implementing certain quantum use cases. But just implementing the hardware is not sufficient, right? We need individuals to show that there is value of this hardware, and there are use cases that we really want to solve which cannot be solved using classical computer today or GPUs today. And
Yeah.
those interesting use cases are what motivate the development and pushing the technology further to achieve something that these use cases can be really implemented on. So that is where IBM has been focused on building the entire ecosystem with the startups, with the organizations, partners, academia, to build that knowledge gap and also provide them the hardware that can be leveraged for various algorithm development and use case implementation.
No, great. I think, yeah. So I keep hearing a lot of stuff. IBM did that and this did that. And yesterday itself, I think you guys had cryogenic modules you can, couple, and you can really build a data center coupling all these cryogenic modules. And that's all very interesting. Now, since you mentioned about that you're playing the whole ecosystem, right? You're building the ecosystem. I have one question. What is the biggest bottleneck do you think, you will see as you scale up? Is it going to be the qubit? Or is it going to be the talent? Is it going to be the algorithm? Is it going to be just the enterprise readiness? Like the enterprise may not be ready to take, because we are seeing that in AI actually, that, there's a lot of hype in AI, but enterprises themselves are not ready to take the AI adoption, those kind of stuff. So of these like four, what do you think is going to be the bottleneck in the industry?
So, sorry, is that question to Enrique or me?
No, to Guncha, yeah, to you. Yeah, sorry.
Okay.
Guncha, you are the person.
Okay. So generally, when you look at, and I have been in discussions with quite a few customers, and I'm sure Enrique would have had his experience as well.
Yeah.
When you get into a discussion with the customer, the first question really is quantum ready today? If not, it is far away. It's a future technology. Then why do I need to invest my time or money today? Now,
Yeah.
something that is missing is that people don't realize that there is some ramp up required to get to basic understanding before you can actually comprehend how some of your business use cases might actually be implemented or your problems might be solved using the quantum devices, right? So that
Yeah.
is where there is lack of knowledge. So you don't
Okay.
have the right talent to make an assessment whether this is really aligning with your strategic view or not. So my answer would be higher. That is,
Okay.
you need to have the right talent. If you don't have the right talent, you don't realize whether you really need to build that into your strategy, because you're not looking to run your company for a year or two. You have to think about your vision for the next 5 to 10 years. And if
Yeah.
5 to 10 years is what your vision is, you need to see how you want to what are your goals, objectives, and how does quantum fit into that journey. Because if you don't start today, you're probably already delayed. Your competitors are probably
Yeah.
doing, yeah,
Yeah.
implementing use cases, trying out utility scale experiments, or as Enrique mentioned, they may be planning to go into production. So I would really focus on talent right now. Getting the right talent
Yeah.
in the organization is quite important.
Yeah. No, no, I also, feel that way. Enrique, what's your view on that?
Yeah, I mean, as Guncha said, talent and know-how is crucial. The typical situation that a startup that produces solutions or algorithms, as Guncha said, is when you approach potential customers, they laugh or they said, "Oh no, AI is delivering quantum is for the far future," and so on. And it's hard to convince them if they don't have a minimal understanding and talent and let's say in-house expertise helps. Now, on the other side, I have to, I study a lot also the way AI is growing, and you hear things like that many of these new Gen AI tools are making coders and developers unnecessary, so more or less the Python times are gone. And people just, if you know this, what people call vibe coding, that you just say, write, or speak, and then you get it, right? You get the code and so on. So I believe in the last months I have been saying that in some interviews that this will impact or should impact immediately quantum. So in the sense that it is coming the moment where you will talk in natural language through agents, and the agents will transform your requests and demands on quantum algorithms. And that needs, of course, an internal package and systems. And in Kipu, we build that, right, such that the customer can speak. But this is a transition that is going to happen in the next months and years. But by now, without the understanding of what is it, the quantum, what can bring, you cannot convince anyone, right? And I like when Guncha said something about the customers, because it's very common that the customer says, so it is not useful now. When it will be useful? In 10 years, then come back in 10 years, right? And like that, you destroy the market and the interest. So I combined a transition, so talent in-house. Second, the possibility to move towards agentic quantum computing approach for the customers, and also to move to something that I call like the reality check, that many top hardware companies, IBM and others, many times ask me how you convince customers, right? And I think that convincing customers implies telling them that they can touch with their hands and see the evidence that the quantum advantage is coming and the usefulness is coming. If you just develop an algorithm for the fault tolerant quantum computer of the future, I'm sorry, but customers will abandon you. We will make a little POC with you and then abandon. The only chance that we have to create a market and this ecosystem is to show some early evidence of usefulness, and that's why my approach play a role. Let's say, right? So you cannot be only I am old enough to have seen for 25 years this promising and promising and promising. You cannot keep promising 20. If you are a country, India, or an ecosystem, I don't know, New York, or you can survive many years. Or if you are a corporate, Microsoft, but if you are a startup and you have a runway and you
Yeah.
have, you cannot just promise and promise. There is a sense of a reality check, and I think that's a way to go.
No, no, great. I think that's a very, very valid point, right? The enterprises, because they pay and they want to see usefulness today, so that is something that has to be demonstrated. Uh, Enrique, what are like one or two case studies you want to highlight where you were able to show customers
Yeah,
usefulness
that's
today?
again, no, I base my answer on what I said at the beginning. If
Yeah,
you ask me where is a universal, scalable, fault-tolerant quantum computer, my answer is come back in the future,
yeah,
who
yeah,
knows how many years. But
yeah.
if you tell me what can I do with the hardware of today, there are two, let's say, technological breakthroughs that Kipu and others have developed and co-developed. That
Mm-hmm.
is what is called the class of industrial applications related to higher order binary optimization, what people call the HUBOs.
Okay,
That, of course, when I say that, people say, oh man, that sounds a little academic, right? But such a core quantum classical hybrid algorithms can impact today on logistic networks, on production scheduling, on FX hedging, and that level of industrial problems. In fact, I cannot disclose more because in India also we have been working with customers. Uh,
okay.
you will get to know along the
Sure,
year.
sure, sure.
But really showing that the customer can see how quantum classical can outperform classical. And on the machine learning side, also with the hardware of today, you can tackle the class of problems that are in the category of what people may call tabular data or time series in relation to feature extraction. And again, this is the abstract part, but this impacts applications like customer churn reduction, where we are going heavily in production with an American bank. We are moving ahead also along, by the way, you mentioned Cleveland Clinic, Mayo Clinic. Cleveland Clinic has also even invested in Kipu. So somehow we know exactly how our technology can impact biosignals, like the case of EEGs or ECGs, and also the class of problems that has to do with satellite imaging or predictive maintenance for drone imaging. So there is a bunch of industrial applications that can see, if not the quantum advantage, the early cases where the customer says, man, this is going to break the market in perhaps not today, but in months or in 1 or 2 years. But if I tell them I offer you an algorithm for the far future, wonderful, then this is a jump in a pool empty of water because you don't know when this will happen. And as a startup, I will disappear. The others can continue, but if you're a startup, that's what I mean. It
Yeah.
matters the context, As a startup, you cannot be only promising. You have to deliver it somehow, and then corporates and hardware providers like IBM have, of course, larger visions, right? But I represent here the necessity of a startup to be alive, to promise a bit, but to deliver a lot.
No, great. I think so this is very interesting, right? So you said that there are optimization problems that can be solved today on using quantum computing. It's a small, step. It may not be like the FTCQ, which, domain that you're talking about. It basically demonstrated today
Not
with
every,
quantum
not every optimization. I was very precise on the higher order
high
because
order.
if you
Yes.
tell me linear optimization or quadratic optimization, my answer is no. If a customer come to me and tells me I have an amazing problem with quadratic optimization, I don't work
Okay.
because quadratic optimization can be solved with millions of variables with classical means. And a quantum computer, perhaps in 20 or 30 years, can compete. Quantum computers can compete today if the class of optimization is higher order, and this exists in logistic networks, production scheduling, FX hedging, and so on and so. So you have to
Got it.
accept. You cannot you cannot play the game, I solve everything. If people come and tell me fluid dynamics, turbulent regime of the Navier-Stokes equations, my answer is no way, I do not work, because this would be a lie. This may be solved in next century. I'm not working for the next century. At least that's my philosophy of work.
No, that's very interesting. That's very pragmatic, and of course, I run a startup, so I understand. You know,
Exactly. You're a startup, right? So you know what I mean, right?
yeah, yeah, those challenges. No, that's very, very, very informative. Guncha, coming to you, right? Although there are a lot of stuff happening today, but the industry, as we have witnessed, when the application, there is a killer application. For example, in AI, we saw the coding actually became like a killer app, right? Just took off. In your view, like, what do you think is the killer? It may be today or tomorrow, I mean, but what is the killer application in quantum computing which will say, oh, wow, this is something that, we would want and those kind of stuff. Just curious about that, yeah.
Yeah, so it's a good way of thinking. So when you think about AI is a tool that everyone has in their hand now, right?
Yeah, yeah.
Everyone is going to use. But I don't see quantum as a tool that everyone needs to use, but the results of the applications of this tool is going to touch
Mhm.
everyone, right? So that is a big distinction that is there. So I wouldn't say one killer app. It is you have to think about it as the use cases that you are not able to solve or the problems you're not able to solve today. Are
Mhm.
there any problems that you can solve in the near term quantum computers? As Enrique mentioned, you cannot solve everything on quantum computers today. Maybe some may come in few years, some may take longer, but we have
Mhm.
to think about what are the kind of problems we will be able to solve sooner. And if we think about those, then something that is simulating nature or optimization use cases, these are the ones that we will start seeing early. You were mentioning about the Cleveland Clinic, Riken, and IBM collaboration on the
Yeah, yeah,
molecule atom simulation, right?
yeah,
Now, within 4 months, we were able to see that from a 300 plus atom simulation, we were able to jump to 12,000 plus atom simulation. Now,
yeah,
this itself shows that there is quite a bit of an opportunity to bring together technologies and knowledge to build and scale the quantum computing to solve bigger problems or to simulate bigger molecules, right? At right now, we are at a level where it can be classically simulated with the approximation methods that we have, and results are good
yeah,
enough. But at
yeah,
some point, classical will reach its limit, and we will need to solve and simulate bigger molecules, which classical will not be able to solve. And that
yeah,
is the level we need to get to. But if we start thinking, oh, it is not yet there, we will not
yeah,
be even able to even think of simulating these problems, right? So that is
yeah,
where we need to start thinking. Coming to the point that Enrique was talking about, the optimization problem, right? You must have seen that announcement from IBM as well a week back. QOBlib was actually open. This is an open source collaboration where
yeah,
community is coming together and they are validating the different problems. So a decathlon of problems have been optimization problems have been identified where quantum computing might be able to really make a difference. And looking at how everyone has validated their results and tested out those optimizations, quite a few optimizations already done and submitted there. This is really a very good example of how the entire ecosystem needs to come together and push the use cases and project to others what can really be accomplished. Then it's a matter of just seeing which is really outperforming and can be adopted for various use cases in the different industries.
Oh, very interesting. And since you mentioned that 4 month, right? That's very astonishing, right? 300 atom to like 12,000 or 20,000 atoms, right? That kind of scale. But that did not happen, right? Because of the hardware scale up. That happened because the algorithm, something happened in the algorithm space, right? Is
So
that my understanding correct?
it's a combination of algorithms and the technology itself. So if you think of quantum computing as the only tool that is going to solve the problems, that is not
Yeah,
the reality. Reality is that not everything needs to run on a quantum computing device. Yeah, some things are done well on classical. You don't need to run that on quantum. So
yeah.
it's a combination and bringing your CPUs, GPUs, CPUs together and running the right workloads, bringing in the efficiency, developing the algorithms that are performing best in these tools. All of this together is what really helps us get to the level of efficiency and the scale that we are trying to achieve. So that is where IBM currently is quite focused on quantum-centric supercomputing. Right now, we have already started building workflows where we can have classical quantum hybrid workflows already done. We have plugins being released as part of the Qiskit component itself. There are additional demos that I'm seeing using the IBM LSF component that has been also demoed in one of the conferences. So there is enough effort being done. And the vision we have is that right now we do have different data centers where CPU is not in the same data center. So there is some latency involved when you're running jobs. There is some queuing required. But eventually, all of these components need to come closer and the latency needs to reduce so that you are then able to execute near time and real time executions and have a much more reasonable response to all the workflows that you need to execute.
No, that's very interesting. And one thing you mentioned, right, which is I think Enrique also mentioned, is the hybrid part, the quantum classical. A lot of times, when we're talking about quantum computing, we're talking about quantum computing in silo, but actually most of the applications or most of the stuff that we're doing is actually a hybrid. You use classical, you use quantum where quantum is needed for, and then you use classical where classical is needed for. And those architectures, as you said in data center, how do you bring together, are going to be interesting. I think IBM is doing some work there, but that's something I want to highlight because at least when I thought about quantum computer, I thought quantum computer, but then started to realize no, it's just not. You have to work with both kind of stuff, right? So yeah, so and Enrique, coming to you, right? You touched about AI and quantum, and that basically is something excites me a lot, right? Bringing AI, combining with quantum compute and those kind of stuff. And both are like pretty, everyone is looking at both these separately. How do we look at it together, right? What is happening in this convergence where AI and you mentioned something about that, but do you want to spend more, you know?
Yes, I really appreciate what Guncha said because she touches something that I admire. IBM created this concept of quantum-centric supercomputing, and
Mm.
in fact, it's not only a vision. The Cleveland work and others is showing the power for chemistry and others. So, and I have to add also that everything I said as useful today and so on, it's hybrid.
Yeah,
And then it is in Kipu, I created the concept of quantum-centric intelligence, not only to be different, original, but also because we were adding the agentic part. And the way I have evolved in my vision of quantum versus AI and all that is that at the beginning, some years ago, we wanted to fight against AI, and it's too late and it's not possible. So I learned that the best way is to coexist and to add forces. So somehow when I tell you it's not that quantum is trying to beat AI, whoever tries to do that, good luck. The idea is to gather forces, and the smartest way to do it is two ways: or AI enhances quantum or quantum enhances AI. We have worked in both directions.
yeah,
So when
yeah,
when AI enhances quantum is what we call agentic quantum computing. Do you facilitate the customer interacting, but the solution will always be hybrid. And the other way is what we may call quantum enhanced tools, where quantum enhanced. So for example, when we set feature extraction, it is a quantum enhanced feature extraction. So we still use classical machine learning and classical AI, but the quantum creates what historically was called quantum accelerator. So the hardware of today can behave as a quantum accelerator. You see, and that's a way. So it's not giving up or declaring failure. It's the opposite. There is an old saying that if you cannot with your enemy, join it. And it's better to join forces with AI because this technology is here to
Yeah.
stay. So instead of saying we want to beat AI, we enhance it. So whatever you give me as AI, my job with quantum is to enhance it, not to replace it. And that's the smart way that we call quantum-centric intelligence, and IBM calls it quantum-centric supercomputing.
No, very interesting, and I like that, they both are feeding each other, right? AI is basically making quantum computing better, and quantum computing making AI better, and those kinds of stuff. So that's a very interesting analogy. Guncha, I know IBM. We have talked about IBM and how they are leaders in quantum computing. I know, and I did not know that till someone told me that IBM does provide some free credits, for running applications. It might be useful for some people to try, right, on actual quantum computer. Do you want to tell about that program of IBM?
Sure. So IBM has multiple programs. First of all, any individual who has an IBM account today, a cloud account, can
Mm-hmm.
log into the IBM Quantum platform and has an open plan available for them to use. Now, this open plan gives them 10 minutes of free access to a select few hardware devices. And when I say select few hardware devices, all of them are 100 plus qubits. They are some of our Heron processors that are available. And this gives individuals the real feeling of running jobs on real devices, right? So they can use 10 minutes in a month.
Okay.
One, if they completely use this 10 minutes next month, again, they will have the 10 minutes and this will keep running. So they have complete access to that. But apart from that, we know that there are academic researchers who may really have a very nice project in their vision. They
Yeah.
have the right skills, they have the right content that they are trying to implement. Now, for them, if they really want to try it on a real device, it is challenging because it really becomes expensive at some point, right? So we
Yeah.
do
Yeah.
have programs for academic members where they have the entire project defined and they have outcomes which really align with what we are looking for. Then there is a program where they can apply for free credits based on which they can actually implement the project and give submissions. Rather, one example that I have is Bits Goa. They
Okay.
had signed up for this free credit program, and they have been able to make an entry into the Quantum Advantage Tracker that is available for anyone to submit, where they have quantum advantage use cases identified, and that is still active. So that is really interesting that just having that free credit program enables academia as well as startups as well. So we do have another such program for startups where if they have a project in mind, if they have a vision and they have concrete development plan, then we do have free credit program that they can leverage in order to accomplish that. At least try it out.
No, no, great to hear. I think that's very, very interesting that that the startups, the researchers, and even like individuals can also use quantum computer. In 10 minutes is huge in a lot of ways, right? Because your simulations are fast and those kind of stuff. So that's
Rather,
very interesting.
rather, I would also like to highlight that there's another startup program that we have where startups can actually become part of our quantum network as well. That is,
Okay.
of course, our strategies and vision align. Then they can obviously submit their application and everything aligns probably. They will be selected to be part of our quantum network. And that gives them access to a lot of other partners and the work that is being done, the insights that are coming out from the research work that is also being done. They have access to that enables them to build a network and also progress on the work that they are doing.
Got it, got it. Is it like I'm just trying to clarify, is this the network that, is it a partner program like Microsoft has or Google has kind of stuff, or is it like a marketplace where I can put my application and people can use it? like
This is more to develop the ecosystem and provide the ecosystem. So we have
okay,
academic partners, members part of that. We do have startups as part of that. We have clients as well who are really investigating and investing a lot in the quantum technology itself from their business perspective. So all of them come together as part and be a part of the quantum network. Generally, these are members who also have a quantum offering that they have signed up for, because then they're actually using the real devices and also executing the experiments on them, right? But for the
yeah.
startups, then this also gives them a way to connect with the wider network while they are experimenting with their offering as well.
Great, that's very good to hear. Enrique, coming to you, right? If any enterprise has to work with Kipu Quantum, right? How should they look at Kipu Quantum, and how uh, what what are the things that what are the problem statement they can come up with, like Kipu Quantum help me?
Essentially, I mean, as you said at the beginning, I am not anymore CEO, so I don't want to overrule
Sure.
the refurbishing, but essentially the principles remain that I created, and they go along the following lines. We try to be as transparent and truthful to the customers. So when a
Okay.
customer comes and says, I need a solution for this problem, can quantum computing can help? If we perceive that this is not going to happen in the next 10 years or 5 years, we just prefer not to work because we, again, without mentioning names of previous startups, because I have tracked the history, many
Yeah.
successful startups of some years ago disappeared, and even though they were creating millions of dollars of revenue per year. And I call this the fictional customer is a customer that pays you for a POC, 6 months, 12 months, and after that they say, okay, given that it's not useful, thanks a lot, goodbye. Then you create fictional customers that will
Yeah.
not create ARR, will not create periodic income.
Yeah.
Then
Yeah.
we
Yeah.
prefer to talk to customers to say, look, if you want to pay me good money, and I am telling you that it will not be useful in years, but you
Yeah.
still want to pay me, we can discuss. But we are not
Correct.
lying. But if we perceive that it's in the category of higher order optimization or machine learning, where we know that there is a case with current hardware or next gen hardware, then we are super excited and we go for it, right? But as I said, not it's not because we are better than others. It's just because as a startup, we don't see ourselves surviving longer with this attitude, right? While
Got it.
corporates, ecosystems, countries can do different,
Yeah.
Microsoft can pass 20 years offering topological quantum computers. They can burn billions and they are still there. But a startup cannot live so long over promising. And that's the way we handle customer relations, by very, but the beautiful thing is that our agents can tell you that already. So if you talk to our agents, the agent will tell you,
Yeah.
guys, thanks a lot, but that problem, no way.
Yeah. Yeah. Yeah.
Yeah.
No, that's very great to hear. Now, of course, time is up, and I just want to make sure that audience gets a chance to ask questions. So, if anyone in the audience has any question for either Enrique or Guncha, feel free to unmute and ask.
Yeah.
Sir, basically, I have one question. I am PhD scholar. So basically, I want to solve max cut problem QA algorithm, quantum approximate optimize algorithm. Basically, I want to try why we have to use in classical optimization method. I want to try only quantum own optimization method. It's possible like that, Kobila, Adam, gradient based. This like that. What can I develop this quantum optimization algorithm? Sir,
Yeah,
it's
I
possible.
mean, if you allow me my answer,
Sure.
again, I'm very pragmatic and I will tell you the truth. Everything that is purely quantum is bound in IBM to today's 156 qubits using the heavy hex architecture or 122-dimensional architecture called Nighthawk, or the upcoming modular multi-chip with Nighthawks and so on. So the number of variables is bound to 100 to a few hundred. Many, or not to say almost all the problems in optimization in banking, in logistics and so on, needs millions of variables. So it's just impossible. So as Guncha said, the solution is to go hybrid. And you have to accept that. You have to accept that. So as I said, or you will lie not to the customer, you will lie to yourself, which is worse. So you have to accept you have to combine classical optimization with quantum optimization. But if you want to use the quantum computers of today, when you reach the quantum computer, you cannot reach to an IBM hardware and to say, oh, where are the millions of qubits for my millions of variables? You cannot do that today. That's not healthy. Many other people do it, but as a startup, I will not do it. And is there a life for quantum-centric supercomputing? Yes. And that's what Cleveland Clinic and others have been doing, and Kipu also, by the way.
Got it.
Okay,
Got
sir.
it.
Another
Sir,
another aspect that you should be looking at is what is the value you're getting by running a completely quantum algorithm. So when you're running any application or running any workload, right? The end goal is to run it as soon as possible. So the cost associated with that is lesser, and you need to get more accurate results. So if you are just running quantum, first of all, you will have to convert your classical data into quantum data, right? That is itself a big cost for you. So you have to look at where you need to build in optimization so that the entire project execution is cost effective for you.
okay. Thank you, sir.
Makes sense.
So much. Thank you, sir.
Anyone has any other question?
Hello, can I go ahead?
Yeah, please go ahead.
Yeah, thank you. Thank you very much for this talk. I just have a question related to quantum machine learning. So I somehow get a perception that classical data today simply does not have enough quantum dynamics involved in order to make use of that proper inductive bias. So having so, can you probably give a commentary on should quantum sensing be the first prerequisite to arrive before quantum ML actually takes through? Thank you.
I mean, again, let us be careful here with the language. So I just raised a flag. The community of quantum sensing is using the term quantum advantage in a very different manner. So you have correct papers, even in Nature published, where they claim quantum advantage even with 1 qubit, because the definition is not computational quantum advantage, but sensing level. So you have to be a little careful with not to confuse that. Yeah, and I would not call that a quantum computer in the usual sense, right? Of course, if somebody can fight and tell me, yes, at the end everything computes. I mean, beyond any metaphysical statement, quantum sensing is a very different technology and extremely useful and can deliver sooner, but it's, let's say, in the best case, a very particular application of quantumness, essentially mostly what people call superposition of quantum states and a little less of multi-parted entanglement. Well, I would say quantum computing is more this digital, analog, general, aiming at really a heavy computational task, right? So yes, quantum sensing is valid. And can you combine quantum sensing with quantum computing? Yes, there are some efforts, but they are very different goals, very, very different goals. In quantum sensing, just to give you an idea, you need to put the device and the quantum sensor in contact with the system to extract the value, you see, while a quantum computer can abstract models and solve algorithms independent of the application itself.
Understood.
I think we
Thank
have,
you, Prof.
yeah, thank you for that. I think we have just time for one last question. Anyone?
Hi, this is Senthil. Can I go about?
Yeah, please.
Hi, I am not a technical in quantum, but I learned some of a QPI program in Bangalore, and I'm working in procurement category, right? In FMCGs like GSK, I worked in Unilever. The one problem which always exists is supplier allocation once we award the suppliers. Like there are various parameters in that to allocate the suppliers to avoid the suppliers. Is it a it's more of a numerical of way of solving rather than AI, right? AI gives a language model. It gives attention language model, like how, what are the attention we have to see in the suppliers parameter when we select it, right? There are risk parameters also, like which is like whether we have to give it to the supplier or not. So in classical computers, we always have the problem to solve and come into the particular way, like how to select this supplier or what this supplier. So is it a quantum way of solving is the right approach in the business model way, or it is not the one I'm doing in a going in the wrong way, right? This is not the real case problem to solve in quantum.
No direct answer, Guncha, perhaps you can.
Connection is choppy. Are you able to hear me well?
Yes, this is Guncha. We can hear you.
Oh, my see. I'm not audible.
No, you're audible. I think Gunja is not audible. So I think Senthil, the answer is not very clear right now, right? You're asking whether the vendor allocation for a procurement cycle,
Yeah, yeah,
is that a valid quantum, problem to
correct.
solve, right? Or
Yeah,
can it be solved by
yeah,
quantum?
yeah. Because why? Yeah, because it will have a same approach, but different constraints will be there. Like
Hmm.
it will be a 20 constraint or 30
Yeah,
constraint,
yeah,
maybe a forex or maybe a supplier risk or banking. Those signals we have to capture and to come into the validation why we select the supplier, right? So numerically we have to present, not like in a
got it.
word or something a subjective. It should be a quantifiable way of allocating the.
Yeah, I think see logistics, shipment selection, and portfolio optimization. These are fairly well talked about optimization problems in quantum computing. And I'm assuming that of course the vendor selection should also be solvable through quantum. Why not kind of stuff, right?
My only recommendation is if you can cast a problem into a native higher order optimization problem, there is hope for quantum today and the next years. If your problem is natively linear or quadratic, try to map it onto a higher order. Otherwise, it's better just to as Guncha said, to keep learning, to keep educating ourselves and keeping moving on.
Yeah. Sorry, is my voice audible now?
Yes, yes, sort of.
Sorry about that. So, Senthil, I would suggest that if you're already able to solve the problem using classical, then I'm not sure why you are exploring quantum. However, if there is a reason why you don't believe the classical is able to give you good results, then as Enrique mentioned,
Yes, classical is not giving a good result because budget versus actual, it is not giving a right number when we do any calculation. And also, right, there is a lot of applications involved in this, right? If you do a budget, we have a different application when we do a execute in operation, that is like a different ERP tool, and then you come into the downstream, then there is a different application teams, right? So we are unable to get that number closer to it. And also, right, there is a again a hookah world. We used to say there is a war or some logistic problem where we will not able to buy it today, or no, will not be able to buy the sugar at the right time, or any packaging material for that sake, right? So the problems goes right, but all the process is similar, right? The process is similar. You have to source, you have to allocate the to a particular supplier, and you need to have a number why we are allocating the supplier, right? Finally, so that process never changed, but the
Yeah, yeah.
problems are
I think
constantly
that will.
back.
Unfortunately, we're out of time.
Yeah, sure.
So I'll interject here, but I think you have a valid point. This problem, I mean, seems like is similar to the other problems that we are looking at from optimization angle. So we'll look at that. But thank you for pointing out that. I think very interesting angle. Now, I want to wrap up here and thank you, Enrique and Guncha, for your time. It was really pleasure talking to you, and we covered a lot of actually ground despite getting into depth in some of the subjects. But really enjoyed, and thank you again, for your time and
Thanks to you all, Guncha, Manoj, and all the team.
Yeah, well, before ending the session, with your permission, can I ask one question?
yeah, quick one, please.
Yeah, thank you very much. Actually, I am a subject matter expert, high performance floorings, right?
Okay.
So let me just give some background. These kind of floorings are extensively being used across different market segments like semiconductors, automobiles, pharmaceuticals, chemical processing plants, and all, right? So now currently I am working at the intersection of uh, uh, my domain and the artificial intelligence, right? In industry 4.0 and 5.0. And beyond my expectations, I got excellent results typically when it comes to digital twins, predictive maintenance, and all. I am new to quantum technology. I don't know anything. So my question is, what are the different possibilities, outcomes, what we can get if we work at the intersection of quantum technology and high performance floorings?
Is Enrique or Guncha, is it possible for you to answer that question?
I would prefer, because of the time, to, I mean, I put my email if somebody wants a specific
Yeah.
question. Second.
Yeah, I
This
think
is
Vishal.
this needs long development.
Yeah, this might need long. So Vishal, thank you for the question, but we'll take it up maybe in the next webinar. We can write to Enrique and Guncha. Yeah, thank you everyone. Bye
Thanks to
bye.
you. Bye. See
Thank
you.
Take care.
you.
Bye
Bye.
bye.
Thank you.
Bye.
Right. Bye. Bye.